Hello, and what we're going to do now is we're going to talk about our first section in Unit 5. This is about marine sediments, and we're going to talk about the dust and dirt that accumulates at the ocean floor. A lot of it comes from the land, and you can take a look at here. Neritic actually means close to shore, and going up to the Arctic Ocean. The Arctic Ocean is a lot of continental margin, just like all the rest of this orangish color you see all the way around. This is the neritic color. We have abyssal clays. These are usually coming away from land masses as dust and dirt, smaller sediments, and they just settle down on top. And we have calcareous oozes, which actually comes from calcium carbonate critter shells and some bones, mostly shells, and siliceous ooze, the greenish color. And we'll talk about what the difference is, and you can see they seem to be in where the blue stuff is not. But basically, all the sediment is made up of all kinds of sediments, but there is a primary type that in each of the areas. So let's jump in. This is a slide you do not have on your packet, and I'd like you to add it, please. This is about sediment icing on top of a mafic cake. So basically, we still have that mafic uh, sediment, the basalts. We actually called it an ophiolitic succession, where we actually have the sediment sitting on top of pillow lavas. Pillow lava showing that the molten rock actually happened and formed in water, came out as a liquid. Below that, we actually have this diked basalt material. And then we go below, we get gabbros and we get ultramafic uh, accumulations, and then we go down and get even more ultramafic, more mantle-like material. And you can see this is about 0.5 kilometers thick. But anyway, this is the ophiolite type material, so it's mostly a mafic floor that's got a sediment icing on top. This is coming from land, and this is a cake, which looks very similar to it, but that's what you're going to find is coming off the shelf and the slope, making a geosyncline here where it actually pushes down due to all the extra weight. But you're going to get this shape um, in the ocean floor of these sediment layers sitting on top of that mafic cake. Sediments reveal a lot about the Earth's history. We actually know that sediments come from the breaking down of large portions of rock. They can be felsic if they're land. They'll be mafic if they're like a sea island or something. But basically, you get weathering and erosion, where you get the breakdown of the rock due to stresses, both chemically and physically, and then they get transported, which is really what the erosion is called. On lower, flatter areas, they can get deposited for a short time. Next storm may wash them away, or they may actually get buried, compacted, and lithified. So we have a starting loose sediment with an aqueous solution in between, and they can get compacted, more compaction, and they actually start getting together. They can also get cemented, where another material moves inside and takes it, and probably the strongest one is going to be compacted and cemented. But this is how we make sediments into sedimentary rock, away from igneous or metamorphic rock or some other sedimentary rock that gets taken apart. But basically, sediments lithified, so we take sediments and we turn them into rock. Mineral composition in the rock actually gives rise to lots of different colors. You see oranges and kind of purples and yellows and other things. This is actually a tile close in the front of a building close to my house, within a couple miles, but to me that's pretty close. Sedimentary texture, where we can actually start with really, really, really fine clays. This tends to settle out of very calm water way out in the ocean. We have silts, which can take a little higher energy, and this particular thing does not show this. This is a modified Wentworth grain classification. We're going to do more about this in a web assignment soon. Then you come up to sands, and you can see you have lots of different sands, and the more coarse the sand, the higher the energy. Coarse sand, very coarse sand, medium sand tends to be beach type environments, and then you actually move into the larger pieces all the way up to boulders. So these are sedimentary textures, and mostly from the ocean. We're going to find from the sands down to the clays. These are usually up in the like rivers and waterfalls, dry land. They can also represent some idea of getting us a past climate. We can tell whether it was a glacier type material. We can tell if it's a tropical type material or anywhere in between, high rain, low rain, all that material. It can also show us about plate tectonics when they get metamorphosed or they get changed in terms of horizontal to vertical alignment because sediments are put down horizontally. They can also show us the age of the seafloor, which we've talked. In fact, we've talked about all these things before. They can also tell us about fossil evolution, how things change through time. This is a kaleidogram where we actually have the formation of whatever this realm of fishes actually would be. And they came up here. There was a evolution event, and we moved this direction, and they evolved into these two things, and then these evolved into this thing plus everything else. And you can see it just keeps moving up and up and up, and they get uh, more and more similar to what we think of as fish today, more complex as we go through. And so these things are all related to this thing down here, but we had some evolutionary event. I don't see any extinction events. They do have some question marks on whether or not that really did come off that leg, but I don't really see any extinction events where the things go up and they end. Sediment classified due to origin. We have 4 different types of sediments we're going to talk about. We have lithogenous, and lithogenous comes from rock. So this is pretty much coming from dry land. Could be an island, but most of it's going to be continental. And there are going to be beaches that are just made of lithogenous type sediments. They're larger than sand, probably not as fun to walk on, especially barefoot, but made of rocks like pebbles, sometimes even boulders. Biogenous means life, and that's going to be coming primarily from skeletons of critters, whether it's calcium carbonate or siliceous. It doesn't matter. It comes from life. We have hydrogenous, which means it comes out of water. These are things like manganese nodules or gypsum or halite deposits, but basically they're coming out of water. They precipitate or fall out of water. And then you have cosmogenous, which means it comes from space. This is the least populous, and usually you're not going to find a cosmogenous sediment. You'll just find cosmogenous material mixed in. And like I said before, these 4 tend to make up every sediment on the ocean floor, but there are areas where it's primarily lithogenous or primarily biogenous or hydrogenous. There really are no areas where it is cosmogenous. Tends to just be mixed in. They're called tektites, and they're basically pulverized asteroid pieces or pulverized silica, and we'll talk more about all 3 of these things. Today we're just going to talk about lithogenous sediments. So lithogenous sediments, these are rock fragments and they come from land. Primarily they're felsic minerals, high in silica and oxygen. They're transported by oceans to oceans by basically gravity, water going downhill, wind pushing things downhill, ice carrying it downhill, and we actually do have gravity flows also where like landslides and things. Showed you an Afghan river. I'm going to show it to you a little bit today, but I showed it to you when we were actually talking about formation of the earth and weathering and erosion and the 3 types of rocks. Rivers transport much of the sediment. If you take a look, we actually have runoff of the Atlantic and into the Arctic Ocean, the Pacific and Indian. We have no runoff, and we have source of glaciated sediments. So if you take a look where we live, right about here, this whole area is actually coming down through and in the Mississippi River and coming out into the Gulf of Mexico or the Potomac or some of the rivers that come over here into the Atlantic Ocean. Same with South America. And the reason is because this is the passive margin, and the active margin is on the west coast of the continents. Tends to get mountains, and the water that falls over here is not going to be going this direction. That's the position of the Rocky Mountains. So everything that falls on the top of the Rocky Mountains has a 50-50 chance, but everything on this side of the Rocky Mountains goes this way, and everything on this side of the Rocky Mountains goes this direction. We actually have this area for glaciated sediments. We have some places where the sediment washes in and it does not get out. You can see there's there's more glaciated, lots of different sections on there. This talks about the discharge, and you can see we have rivers that discharge a lot of water. We tend to think of the Amazon as being a big river, or the Mississippi, but you can see we have some rivers over, especially coming off the Himalayan plateau, these areas right here. And you can actually look at the area, the numbers on there. So Colorado River, Mississippi River, the Amazon. But if you take a look at the rivers over here, they're putting in a lot more sediment, especially this one right here, which is coming directly off the Himalayan plateau in China. Both lithogenous or terragenous, this means earth-born sediment, because the book of Genesis, the first book, Genesis, means where you originate. This originates from rock. They accumulate near the continental margins, and they're called tectonic soils. Mostly they're made out of quartz, silicon, and oxygen again. That tends to be a much more chemically stable mineral, more long-lived. It doesn't submit itself to weathering and erosion, especially the chemical weathering, which dissolves it into its molecular material. It also is a very good abrasive and very resistant, and this is what tends to wash away a lot of material, rub away a lot of material like sandpaper. Wind-blown dust in deep ocean makes abyssal red clays. This is the red clay in Africa that's actually being kicked up by a windstorm, and if that windstorm continues, it may actually end up blowing the material from Africa right over the Atlantic Ocean. It can blow all the way over to North America. They're thinking a lot of this is the problem of the coral reef. It actually gets in the water, falls on the coral, blocks out sunshine, starves the coral, kills the coral. And you may say this is a natural occurrence, but primarily it's because we are turning in all this land into more of a desert by pumping out water, which eventually pumps out salt and actually saltifying the land. Texture of terragenous sediments, grain size indicates energy and transportation as well as deposition. We talked about the Wentworth scale, where we actually start from very fine sediments all the way up to the very large sediments. This is an erosion, transportation, deposition. And if you take a look, clay, it doesn't take much velocity to actually get it to go. To transport it, it takes a little bit to actually pick it up. In fact, it takes as much energy to pick up clay as it does probably pebbles because of the size. So basically what this thing is showing you is that the transportation doesn't take as much energy as it does to pick it up to move it. So material stays on the ground, it gets picked up, and eventually will get deposited. It doesn't take much to deposit a boulder, so it actually, you can see that it takes very fast water, and the boulder actually stops moving. Sorting indicates a degree of reworking, or how it actually is flown. If it actually is very coarse type material, we actually know that it hasn't gone very well. If it starts getting sorted, unsorted versus sorted, we know that it's moved well down its path. Roundness, if it's an angular type material, it's way up in the mountains where rock falls on rock and breaks. If it's more rounded, it means it's down farther in the river. And spherinity, where we talk about how spherical it is, the more spherical it is, the more it actually shows that it's been worked. So texture maturity also indicates the amount of reworking. This is the river of stone. I'll click it really quickly and show you. If you remember, I showed you this river, and as it goes through, carrying large parts, they're very angular, so it actually shows it pretty well. And it goes on for quite a while. It flows into another river. You can actually see how high the water was just a little while ago. It's actually comes out, it's a rain-soaked area way up top above the mountains, which carried all this stuff down, and it actually is moving into a much faster moving stream. Texture maturity. Degree of soreness actually increases as it goes downhill. Clay content decreases as it goes downhill because it tends to dissolve in water, and the roundness of the sand particles actually increases as we go downhill. There's another link down here to how sand is going. I didn't say how long this is. I may show this to you in class. I don't want to show it now because it's going to make this video a lot longer than it is already. Distribution of terragenous sediments. Neritic is mainly lithogenous. They tend to be closer to shore. The neritic zone is basically over the continental margin. Coarser material, showing higher energies. Beach sands, the coarse sands, the fine sands are farther out. Continental shell deposits, critters that actually like to live near continental shelves. Turbolite deposits, the turbidity currents that we talked about, and glacial deposits. We also have what are called pelagic. Pelagic actually happens in deeper water, so farther away from continental margins. You do get finer particles because it's farther from land. The coarser ones fell out first, and all because of lower energies. But you also get that wind blown or distal turbolites. Turbidites actually are showing you material falling down. The reason these are called distal is that they actually happen from far away. So the African one, if this is North America, African coming from all the way over here, dust particles fall out into the ocean, and they do form turbidites, but they're distal rather than regular turbidites, close to the neritic zone. And that's where we're going to stop. That's the end of terragenous sediments. So we'll finish up the other sediments on the next video. Thanks for stopping by.